For today's video we have RDNA2 versus RDNA3 IPC. IPC means instructions per cycle, and what I'm trying to do here is show you how much faster or how much better RDNA3 is compared to RDNA2. So RDNA3 RX 7000 series versus RDNA2 RX 6000 series in terms of architectural performance. And to do that, we ideally need the same amount of physical units for a card of each generation. For example, an RX 6000 series card with the same amount of computer units, cores, TMUs, ROPs, cache, buzz width and so on as a 7000 series card. And in this case, for the higher end, we have the RX 6950 XT and the RX 7900 GRE. Both featuring 5120 cores, 320 TMUs, 80 computer units, 256-bit buzz and 16GB of GDDR6 VRAM, being the only difference the number of ROPs that is lower on the 6950 XT and the L3 cache that is half on the 7900 GRE. And even with the RDNA3 cache being much faster, it can still make the difference in some scenarios. But don't worry, as more cards will be tested, but we'll get there. As soon as you lay an eye on today's sponsor. Have you ever wanted to upgrade to a larger disk but didn't want to lose your Windows installation and programs? Just use EaseUS Disk Copy. EaseUS Disk Copy allows you to create clones of any partition or disk, making you able to move your operating system and files without the hassle of reinstalling everything from scratch.
Oh my!
And it even allows you to create bootable disks for your Windows or Linux installations, for example. And this, with a simple interface allowing new users to easily use it with one eye shut. Lay an eye on EaseUS website, where you can get the EaseUS Disk Copy for free and later upgrade to the Pro version according to your needs. Now, since these cards are very similar, we can kind of measure the generational uplift in this case, not lift, the generational uplift of RDNA3 versus RDNA2 if we lock the cards at the same exact frequency. And in this case, we'll have the overclocked results, which are around 2.6 GHz core frequency for the 6950 XT and up to 2.8 GHz core frequency for the 7900 GRE. And then we have the two cards locked at the same frequency of 2.4 GHz on core. All configurations run the same 2200 MHz VRAM in order to be as accurate as possible. So with this all stated, let's see how much better, or not, RDNA3 is. Our first game is Avatar: Frontiers of Pandora, and in this case both cards are really close performance-wise. In fact, I would say that in terms of ray tracing, since this game uses it, we saw basically no difference besides the higher 1% lows on the 7900 GRE. But it still amazes me to see such close results here. I guess the L3 cache might be playing its role here, with the 7900 GRE having only 64 MB. Lies of P uses Unreal Engine 4, which is a considerably old engine, and that's why we see such a small difference once again, with the GRE being only 5% faster overclocked and 7% faster at 2.4 GHz. I guess RDNA3 really needs that extra bandwidth and cache on the top tier cards at least, I guess. As we move to Banishers Ghosts of New Eden, a title that uses the newer Unreal Engine 5, we finally see a noticeable difference. Not big, but noticeable, with the GRE now being 11% faster overclocked and 13% faster when locked to 2.4 GHz, which is not bad per se, but we at least get 10% improvement at the same clocks and with less cache, which in my book is actually quite decent. Cyberpunk 2077 is another game that takes advantage of the RDNA3 architecture, and I already knew that due to the amount of tests that I've been doing across the years. And here we have the 7900 GRE being once again considerably faster than the 6950 XT, in this case 13% faster overclocked and 12% faster at 2.4 GHz. Nothing really astonishing, but it is there. As for Dragon's Dogma 2, it uses the Capcom's RE engine, also used on the Resident Evil games, and here we have a smaller uplift compared to the Unreal Engine 5 games, with the 7900 GRE being only 6% faster overclocked and 7% faster at 2.4 GHz. It is worth mentioning though that RDNA3 cards deliver higher 1% lows, at least this one here delivers higher 1% lows, 16% higher overclocked and 15% higher at 2.4 GHz. And as for Starfield, it also uses Bethesda's own game engine, which is not that new as well, and it shows, as the 7900 GRE is only 7% faster overclocked and 5% faster at 2.4 GHz, showing that the IPC difference doesn't really affect this game that much, which is a bummer. Horizon Forbidden West is more or less like Starfield as it uses the Decima engine, which, truth be said, is an excellent game engine, and that's why we actually see both cards on par in terms of performance, which is actually mind-blowing, meaning that in this game, the 7900 GRE with even more physical units, a bit more, but running a newer architecture and with higher frequencies, delivers virtually the same performance as the RX 6950 XT. Maybe having double the L3 cache is a plus for the 6950 XT here. Alan Wake 2 is one game known to feature lots of new technologies under the hood, like mesh shaders for example, and from what I understand the game is always using some kind of software ray tracing like Lumen 2. And in here we can see a decent difference, with the 7900 GRE being 13% faster overclocked and 15% faster when locked to 2.4 GHz. It's odd to have a bigger difference when locked to the same frequency though, meaning that the 7900 GRE might not be able to boost higher due to the power limits, which is always interesting. And want an odd scenario? Well, welcome to last Epoch, where the 6950 XT is faster than the 7900 GRE. You heard it right, faster. I don't know if this has to do with the driver version or the game itself, or even with the amount of cache in both cards, I don't know. What I know is that we tested it several times with both cards and the results came out exactly the same. Again, maybe there was some driver conflict or the game just likes RDNA2 better. Who knows? Moving to Call of Duty Modern Warfare 2, we have a game that makes a very good usage of the RDNA3 architecture, with the 7900 GRE being considerably faster than the 6950 XT, 25% overclocked and 20% when locked to 2.4 GHz. I guess this game can take advantage of both the architecture and the extra frequency of these cards. If all games come to be like this in the close future, well then the RDNA3 cards would show some very good games. Now we have Resident Evil 4 that uses the same game engine as Dragon's Dogma 2. And as seen before in that game, the results are pretty close. Even with ray tracing set to high, the newer RDNA3 card is only slightly faster, something that would not be noticed in real gameplay. And I mean, RDNA3 cards are supposed to be better in terms of ray tracing, and yet we see almost no performance difference here. As for PUBG, at stock or maximum frequency, both cards seem to be hitting a CPU bottleneck or something close to that, with identical FPS. But as soon as we lock both cards to 2.4 GHz, the 6950 XT loses a lot of ground and the 7900 GRE is now 9% faster. Still, this seems to show once again how RDNA3 cards need that extra bandwidth to put those computer units to work, and maybe some more cache would help too. Fortnite it is now, and in this case, even though it uses Unreal Engine 5, the difference we have between both cards is basically null, with the RX 7900 GRE being barely faster than the 6950 XT, even when locking the frequency to 2.4 GHz, showing that in some cases RDNA3 is either barely faster than RDNA2 or really needs more bandwidth and cache to perform as intended. As for the averages, we can see that the RX 7900 GRE at 2.4 GHz is only 6.4% faster than the 6950 XT at 2.4 GHz, and sometimes it even consumes more power, which is outrageous, but I'll show you that in the end of the benchmarks, of course. And even if we take last Epoch out of the equation, since it is an outlier, the difference is still around 9%, which is subpar compared to older generations, with OC versus OC difference being even lower than that. RDNA2 versus RDNA3 in terms of gaming, well, basically it only performs considerably better in terms of newer game engines, but since that's where we're heading, it doesn't seem that bad. As you saw, the performance difference is not that much in terms of gaming workloads, and that led me to test one of the things where RDNA3 is kind of supposed to have improved the most: productivity. In terms of productivity, we start with Blender Open Data with the 3 scenes average, and we can see that the 7900 GRE is a bit faster overclocked, even though the difference is almost null, but when we use both GPUs with the same core and VRAM frequencies, the 6950 XT is basically on par with the 7900 GRE, which is quite disappointing for the RDNA3 ARC. And with Cinebench R24, things don't change much. This time we have the 7900 GRE being 5% faster overclocked and 3% faster when running at the same exact frequencies, which once again is a bummer. But if we consider the 7900 GRE as 33% more compute units and only performs around 15% faster than the 7800 XT, we can understand that higher tier RDNA3 cards need much more Jesus Christ, need much more bandwidth to work as intended. And the same exact thing happens with the Puget benchmark, where both cards are very close in terms of overall performance, but now, when using the same frequency, the RX 6950 XT was somehow faster, which makes no sense at all. And to finish the benchmarks of these two cards, we have a newly added benchmark of Stable Diffusion 2.1 using the Shark AI with Vulkan, since Rockham somehow gave me lower results. And in here we're showing the average step time in milliseconds, meaning that the lower the values, the better the results. And we can see that the 7900 GRE performs just a bit better overclocked, but I can tell you that the software seems to not make use of the AI cores on this card in particular. How do I know it? You'll see in some moments. And now you know that RDNA3 is not much faster than RDNA2, at least in this very specific scenario. And I know that the RX 7900 GRE is kind of an odd card, and it might not be performing as it should in some scenarios, sadly, and I suppose that's due to the fact that RDNA3 needs much more bandwidth in order to feed those extra physical units or those compute units. So having way more compute units, but not having enough bandwidth to feed them, well, just won't deliver that much of a performance uplift. So I went further and decided to test some more games, to benchmark some more games with two extra cards, the RX 6800 and 7800 XT. These two cards are even more look-alike than the previous ones. They both have the same exact physical units, being the only difference the amount of cache that is also half on the RX 7800 XT, 64 versus 128 megabytes. But once again, the cache presented on the RDNA3 cards is much faster. So let's see how these cards compare to each other, both locked at 2.4 GHz and with the OC profiles that you see here. Now with the 6800 versus 7800 XT, we start with Starfield, and since the clocks are lower on the 6800 non-XT cards, this time I lock the clocks to 2.2 GHz instead of 2.4, and also tested at 1440p ultra-wide in order to be different. And you can immediately see that where the 7900 GRE was barely faster than the 6950 XT, the 7800 XT is 20% faster OC versus OC and 19% faster when locked to 2.2 GHz, showing us that the GRE is indeed a node card and the IPC increase is indeed real. And even in last Epoch, where the 7900 GRE somehow performed like crap, we get the 7800 XT being now 12% faster at the same 2.2 GHz, which is nothing astonishing but much better than being slower than the older generation counterpart. RE engine titles also didn't show much of a difference on the GRE, but with the 7800 XT we get an entirely different scenario, with the 7800 XT being 20% faster OC versus OC and 16% faster with both cards locked to 2.2 GHz, which is a pretty good result if you ask me, especially compared to the GRE1. And with PUBG we get exactly the same. It seems that RDNA3 really needs that extra bandwidth, and that might be where the GRE lacks, not being able to feed most of those extra compute units, I mean. In terms of results, the 7800 XT is now 16% faster at the same frequency and 19% faster OC versus OC. And Fortnite is an Unreal Engine 5 title that didn't show a real-world difference on the GRE versus the 6950 XT, but in here things are different. Even though the 1% lows aren't much higher, the 7800 XT is on average 12% faster at 2.2 GHz and 16% faster with both cards overclocked. Still, could be better, I guess. With Cinebench R24 the results are within the expected, with the RX 7800 XT being 10% faster at the same frequency and 15% faster with both cards overclocked. It is although interesting to see that in all these games, even with half the cache of the 6800 I mean, the 7800 XT is still outperforming it at the same clocks. Although I should note that L3 cache is much faster on the RDNA3 cards too, so that's also a thing. And remember what I told you about the GRE not being properly used by Stable Diffusion with Shark AI? Well, here's why. As soon as the AI cores on the RDNA3 cards get used, the difference is just massive. While the GRE was barely faster than the 6950 XT, the 7800 XT is almost 3 times faster with both at 2.2 GHz and more than 3 times faster with both cards overclocked. So if you were thinking if the AI cores, well, in your card were working or not, well, you have the answer here. And well, things were quite different now, weren't they? I even tested most of the games where the 7900 GRE wasn't really much faster than the 6950 XT, and even in those games, the 7800 XT was considerably faster than the 6800 non-XT. And with this you might say, well, but the 7800 XT did have higher VRAM frequencies, and the 7800 XT features a multi-chip module design, while the 6800 features a monolithic die, sorry. And I mean, lots of you guys told me that on the community tab and also on the X post that I made. So I went once again even further and tested some more games and synthetic benchmarks as well on the 6650 XT and RX 7600, which are exactly the same. They feature the same cores, the same cache, the same frequencies, VRAM and so on. I can lock them exactly to the same, exactly equal, and both feature a monolithic die design. So let's see how the same card performs in two different architectures. With the 6650 and 7600, I still tested with the 5800X3D as the CPU, and this time at 1080p, well, since both these cards are entry level nowadays. And testing Avatar once again, it shows that we do have some really odd results as we had with the GRE, with both cards being very close in terms of performance, well, in this case scenario at least, although when locked to the same frequency, the 7600 is 6% faster. But as soon as we overclock the 6650 XT as well, things get basically the same. As we go to last Epoch, the results get on the regular path, let's call it that, with the RX 7600 now being a good 15% faster at 2.4 GHz and 11% faster when overclocked. And I believe the reason why we get lower differences with overclock is the 7600 hits the power wall in this game and can't boost much more over the 2700 MHz even at 1080p, while the RDNA2 card, the 6650 XT, works differently and plays this game at 2900 MHz locked, and that makes a difference. PUBG shows us more of the same, which is actually good, with the RX 7600 being 11% faster at 2.4 GHz and only 5% faster with both overclocked. And once again, this happens because the 6650 XT just maintains 2.9 GHz across the board, while the 7600 needs to decrease the clocks in order to be inside the power limit. And even then, it is still a bit faster than the 6650 XT, so not bad. Fortnite also shows some interesting results. 13% advantage for the RX 7600 with both cards at 2.4 GHz, but only 6% faster overclock versus overclock. In games where both cards are able to maintain the same clocks, like Assassin's Creed Mirage, Call of Duty and other games, the difference will be even higher overclock versus overclock. But generally that won't be the case, as you have the RX 7600 model with a really over-the-top power limit, unless, of course, I could test the 7600 XT that has 240 watts power limit, and in that case the results would be much better overclock versus overclock. But since that card has 16GB VRAM, the results wouldn't be entirely accurate. And to finalize, we have the AI benchmark, once again with stable diffusion, and as soon as the AI cores are supported, the difference is huge. In this case, at the same frequency, the RX 7600 is around 2.7 times faster than the 6650 XT, which is insane, with the overclock versus overclock results making it around 2.4 times faster. Still a huge win with the RX 7600 here. Let's get to the final thoughts. And with the cards being exactly equal, we had more or less the same results as we had with the 6800 and 7800 XT. I need to say that the 7600 was kind of power limited in some scenarios, unlike the 6650 XT, and that's one of the reasons why you see the locked frequency results having a higher difference in terms of percentage than the overclocked ones, because in most scenarios the RX 7600 needs to decrease the clocks a bit, needs to decrease the frequency. I'm even stuttering. It needs to decrease the frequency a bit in order to keep itself inside that power limit. In this case I believe it's 200 watts, while the 6650 XT just doesn't care about that and keeps itself always at 2900 MHz or a bit more than that. And that's why at 2.4 GHz, when both cards are inside their power limits, the difference is bigger than one overclocking the two cards, since the 6650 XT keeps itself once again at 2.9 GHz or more all the time, while the 7600 needs to come down a bit in frequency in some games, sometimes to 2700, sometimes to a bit less than that, in order to keep itself inside the 200 watts power draw. The two cards function differently in terms of boosts and power limits, but still it is a very realistic result, as both cards work exactly this way in real world. When you're seeing the power draw with MS Afterburner, the RDNA3 cards will show you the total board power draw, while the RDNA2 cards, I believe, will only show you the core power draw, meaning that on top of the core you have the VRAM power draw, you have the LEDs, the fans and so on, and although those things don't consume as much as the core, they do consume more power. So imagine that the 6650 XT is, let's say, showing 175 watts, while the 7600 non-XT is showing a maximum power draw of 200 watts. That means that both cards are more or less consuming the same, as you need to have, on top of those 175 watts, you need to have the VRAM, the fans, the LEDs and so on, so on, so on. So that's a thing. Total board power on the RDNA3 cards versus the core power draw on the RDNA2 ones. That makes a difference. But if you really want to see it, well, due to how both architectures work in terms of boost clocks and power limits, things wouldn't be accurate, as I said before, as in some games like Modern Warfare 2, the RX 6950 XT at 2.4 GHz may show, let's say, 30 to 40 watts less power draw, meaning that it should be within, let's say, 10 to 20 watts of the 7900 GRE maybe, as the 6950 XT once again only shows the core power draw, while in other games like Cyberpunk 2077, the power difference shown with MS Afterburner might be even smaller, showing that both are consuming around the same power at 2.4 GHz, but the RX 7900 GRE is, well, considerably better in terms of performance. What I mean with this is that I'm sorry I cannot bring you better results in terms of this, because once again I needed to be seeing the power draw at the wall in order to be more accurate, as total board power versus core power wouldn't be, well, sufficient for me. But in most scenarios I believe that the 7900 GRE and the 6950 XT at the same frequency of 2.4 GHz will be consuming more or less the same. But if you push those frequencies to the maximum, usually the 6950 XT consumes a bit more. It can reach like 350 watts on core only, while the most I saw in terms of total board power of the GRE was like 340 watts, and that's with a Nitro Plus model. Usually the Pulse and the other ones go up to 290 watts. So it kind of depends. RDNA2 versus RDNA3 is kind of different, once again because of the boost clocks and the power limits. So the model might affect the performance and so on, so on, so on. Even more than it previously did. And well guys, that's all for this video. Thank you very much for watching. Overall, we did see that RDNA3 is usually better and more performant, let's say that, faster in terms of IPC. At the same frequency, it is usually faster. We compared at least with the 7800 XT and the 7600. As for the 7900 GRE, there are some games, usually newer game engines that can take more advantage of the RDNA3 architecture. That's where the GRE is usually faster, but overall it isn't as fast as it should be, and I believe once again that's due to the lack of VRAM bandwidth, as well. It should have more, like the 7900 XT, but I believe they didn't do that, because if they added more bandwidth to the 7900 GRE, it would be really close to the 7900 XT, and they don't really want to do that. And that's one of the reasons why they also lock the maximum frequency to 2.8 GHz instead of 3.0, 3.1 or 3.2, and they also lock the VRAM frequency. And even though you can overclock it, it just won't perform the same as the other VRAM does on the higher tier cards, because the timings are different. But that's a story for another video. Thank you very much for watching. Don't forget, leave your comment in the comment section and let me know what you think about these results in terms of IPC and in terms of the several cards results. For example, in terms of the AI cores, where the newer cards perform much better with Shark AI and Stable Diffusion, really much better due to the dedicated AI cores. And although it seems that the 7900 GRE is it's not yet supported, but overall the 7000 series cards are much better there. So leave your comment in the comment section and let me know what you think. Thank you very much guys, and see you in the next video. Cheers.